All right. Then the full screen here. All right. Demo. 2 examples. The first one, drag and drop, but for jQuery. jQuery implementation, drag and drop. Yeah. All right. So here, let me see if I already have it opened. Yeah, not there. Yeah, let me open it. Yeah. Drag and drop JQ. So when you see this JQ, that's the jQuery version. Yeah, all right. So the same thing as you saw last time, yeah, but implementation is different. Yeah. jQuery. So let me show you the source code. The source code, you can see we need to add these links, these 3 links, in order to do jQuery implementation of drag and drop. So here you can see, first one, jQuery. Then, second and third, we need a jQuery UI package, jQuery-UI. Yeah? Usually, when we use jQuery, we do not use this UI part. Okay? Yeah, but for this drag and drop, we need this UI special package. You just include 2 links, one CSS features, another, JavaScript, the extra JavaScript package for the jQuery. Yeah. All right. Other than the links, then HTML, you do not need to do anything. Okay? Yeah, just original HTML. You do not need to do anything special. All right? Yeah? Yeah. And no JavaScript functions. See here, no JavaScript functions. You can compare with our JavaScript version. JavaScript, each element we associate with a JavaScript function. Right? Yeah? So you can see, compare. Yeah. Then, in the jQuery function, you can see very simple. Yeah, let me show you. You need to provide a, JavaScript function, but you need to write jQuery code inside. Yeah. Here. So let me show you. Yeah. So simple. See? Function, all right, inside $span element. Here, double quotes span. That means we want to make all span elements draggable. That's it. Yeah. Because the UI package takes care of all the, details, all the, underground, behind the scene work. Yeah. You cannot see the UI package take care of that. So we do not need to write any code. If you look at our JavaScript implement, we write a lot of code, right? Event-driven. Yeah. We need to get an event object. Then from event object, we need to control, right? Coordinates. Yeah. So that's the JavaScript implementation. Here, we just make selected elements draggable. You can make other elements draggable. Yeah. Here you can see jQuery version is so simple. So simple, yeah, yeah. But I like you learn both versions. Yeah. JavaScript version, although more complicated, but if you want to add some, for example, some extra control, right? You can put extra control in the JavaScript functions. But here, you do not have control. All the control goes to jQuery, right? You do not have control. For example, what kind of control I may like from JavaScript? I may like to store the coordinates, right? your actions, which point you move from which point. If I want to store that data, I can use JavaScript function to get. But here, you do not have that control, right? The coordinates, yeah, you do not control the coordinates, all right? Yeah. This is the first example. Second example. Yeah. Second example, I also explained the code last time, but I didn't show you the example. So this time, I give you that example. Hide and show feature, right? We compare JavaScript version and the jQuery version, hide and show a particular element. Here, let me run that example, hide and show. Yeah. I use tangram, okay? I draw the, tangram, that square. Yeah. I include that image, but I display left-hand side, right-hand side. Left-hand side, that's the JavaScript implementation. Right-hand side, jQuery implementation. Yeah. Same feature. So regular hide, we hide it. Okay? Regular show, we show it. Yeah. All right. JQ hide, jQuery version hide. Yeah. One function, hide function. Yeah. jQuery version show, yeah. So you see show function. Yeah. Very simple. Okay? Yeah. Yeah. So you just compare, the difference, how to use these two different ways to do the same thing. All right. So today I just show you, these two examples. Yeah. So next time I show you our project example, a demo. So I wrote a, demo for the project. Yeah. So then I show you, the main features we need to do. Yeah. In the tangram puzzle. Yeah. Tangram puzzle, each piece we need to make draggable. Here it's not draggable. All right. So here not draggable. Yeah. Yeah. Next time I make each piece draggable, and we do rotation. We do, put it in a destination location, make a different figure. Yeah. All right. Yeah. So now let's go to Part D topic. This one, last topic, but it's important. Yeah. So what's that? Data format in database, but we did, traditional data format. This time, we want to look at social media data. Yeah. Oh, I need to connect my remote control. Yeah. All right. Yeah. The social media data is quite different from traditional data. So we call it non-traditional data. Yeah. So let me start. Yeah, PowerPoint slides. Pen color. Okay, all right. Yeah, so why the social media data is so special? It depends on how we use the data. The way we use the social media data and the traditional data quite different. There is a main different feature, main different usage. Usage different, okay? All right. So here, we compare the data usage. All right. Traditional and non-traditional. Non-traditional, the social media way. The main difference for non-traditional, we know there is a huge community, right? Keep posting data in social media. So the main usage for social media data. A feature, so the data available immediately. Main property. After one user posts a message, a post, then it is available to the whole community immediately. That's the typical property, right? But for traditional data, it may not be available immediately because after the data is added to the database, some data processing needed. Yeah. Certain data process could be needed. Yes. Yeah. Yeah. May. So, may need some data processing work. All right? Yeah. Yeah. That's the key difference. Yeah. For example, let me use search engine as example. Google search engine. Google search engine, so for example, if one website is created and make it available to the whole world, one web page, it takes some processing time for Google search engine to make it available to the whole world. It's not immediately, all right? Yeah. Because they need to do a lot of behind-the-scene data processing before that web page is available to the whole community. Yeah. But social media, after you post it, hashtag, yeah, you put some hashtag, then available through hashtags immediately, all right? Yeah. Traditional data, no hashtag, right? Yeah. So the traditional data, in order to make your data available to the whole world, Google search engine need to do some indexing work. Indexing work. Yeah. So it takes some time. It takes some time to do the indexing work. Yeah. I will talk about details, in the later a few lectures, yeah, because that's a big important case study about the data. Yeah. All right, so here, let's look at the non-traditional data format. Then the format is quite different. The format should be very simple. If the format is very complicated, then you may need a processing time. So here the idea is no processing time. Okay? So the design goal of the data format, make it available immediately. As soon as it is posted, it is available immediately. That's the main requirement of the social media data, all right? So posts, tweets, images, video clips, on social media. Yeah. How do you organize the data? You need to give it a format, right? The basic format. Yeah, you need to define some easily processing format. Still the processing, but the processing is, at the same time. Yeah, the processing is real-time processing. Okay? Yeah. No extra time process. Real-time processing. Yeah. On the fly. Yeah, the processing. Yeah. Large data amount. Yeah. Large data amount. So that means if you need to do some internal data processing, then too much work. Think about if the social media data, if you need to do some internal data processing, then large amount of work. Yeah. Yeah. So then, you need to put some structure, but the structure should be as simple as possible. So what's that data structure? Yeah. There is only one single format for the to describe the structure of the data. So what's that data? Key value pairs. Yeah, so let me explain this key value pairs special. First, it's simple, right? Two components. Key component. You need to have a key. Okay? Key. What's the key? Hashtag, right? What's the hashtag? The hashtags, those, strings are used as the search key. Why you use hashtags? For search, right? Search keys. Yeah. So the key part. Value, what's the value? Your post is the value. Okay? Yeah. So you have the search key, then the data value part. Yeah. So you organize your data as key value pairs. Yeah. Each data item is one key value pair. Yeah. That's one data item. Okay? Yeah. So then all of your data organized in large number of key value pairs, supporting key-based search, and the search tool can provide the result immediately. No indexing step. Indexing step, later I will talk about Google search engine, the indexing step. A lot of data processing. Many powerful servers, and they need to do a lot of work to generate pre-processing data. So here, key value pair, no pre-processing step. All right, yeah. Traditional data, in the search engine example, a lot of pre-processing work. Yeah. So you can do the comparison. Yeah. All right. So key value pair, all of your data items are in key value pairs. Then you do not need other descriptions, right? That's the only format you can use in social media. Only this format, no other formats. Okay? Yeah. All right. Then you will see another property difference between traditional databases and non-traditional databases. So here, non-traditional databases. Yeah, because data is so simple, then when you design databases, also much simpler than traditional data. Traditional databases are very complicated. You will see. Yeah. We could be very complicated, but non-traditional, simple. Yeah. All right. Yeah, so here we refer to NoSQL, meaning not only SQL. Just a name, not only SQL. Yeah. So why? Because, yeah, so you can, different people can understand differently, but here, one important understanding aspect is, do not try to replace traditional, no. So non-traditional databases are not created to replace traditional, no. They work on different part of the world, okay? The traditional, let's say 90% of the business world. Non-traditional, about 10% of the business world. Yeah. So different parts. Yeah. So not trying to, it's not a newer version of traditional database. No, it's not that. Yeah. They both of these two types are needed. Yeah. I need to use that one. Yeah. Otherwise, features disabled. Yeah. All right. Yeah. So here you can see working on different parts of the world. Traditional, what kind of data processing we need for the traditional data? Sophisticated data processing. If you want to work on your business data in some very sophisticated way, you can imagine, manipulate your data in a very complicated way. Then you have to use the traditional data, because non-traditional does not support that kind of sophistication. Okay? Yeah. Non-traditional data emphasizes simplicity and fast. Yeah. Yeah. The most important thing is fast access. Yeah. Most important requirement for non-traditional data, fast access. Yeah. Yeah. So it must be very simple. Yeah. Yeah. All right. Yeah. Traditional databases, relational databases. Yeah. Relational, you have large number of tables, and when you need to explore the relationships among those tables, you need a lot of data processing, the query, complicated query work. That takes time. Yeah. If your query is very complicated, then the data processing time could be quite long. Could be quite long. Okay? Yeah. Some of the queries, huge queries, it could take a long time. Okay? Yeah, but for non-traditional, you are not allowed to do that kind of long time processing. Yeah. Yeah. Otherwise, the users won't be patient, waiting for the response. No. Yeah. So you need to understand the main difference for these two different types of data. Yeah. Much simpler than relational databases. The structure much simpler. Query also much simpler, because the structure is so simple. Okay? And then you do not try to explore relationship. Yeah. You do not try to explore relationship. Okay? Yeah. If you need to explore relationship, then you need to switch to the traditional databases. Okay? Yeah. Just use the social media data in a straightforward way. Yeah. Yeah. All right. Yeah. All right. Mainly handle relatively simple but a large amount. Yeah. Simple but a large amount. Every minute in the world, large number of posts, new posts in the world. Yeah. So that you need to do that kind of typical work, data processing work, quite different from traditional databases. All right. Yeah. Supporting fast search. Yeah. All right. Yeah. Relationships. Now replacing traditional databases. Yeah? Yeah. So they work on different parts of the business world. Yeah. Augment traditional databases. But you can see the traditional databases cannot do this part well. Okay? The traditional databases cannot handle the social media data well. You can see augment, so that's why it's augment. Yeah. If you want to use traditional data to manage your social media, too slow. Okay, so it's not good. Yeah. Result won't be good. Yeah. That's the reason this NoSQL databases were created for the social media, typically for the social media applications. Yeah. All right. Yeah. Later, when we study the detailed structures of the traditional databases, we will do comparison. Okay. Yeah. When we get some point, we will compare some aspects of the details. We try to understand better. All right. Then demo, basic DBMS operations. Yeah, yeah. Today, yeah, because today I already, a lot of time passed. I already did one demo, so yeah, let me leave some demo operations later. So every time we just do 10-something minutes demo. Yeah, we do not do too long. Yeah. So let me jump to Module 2, Part A, because we have some advanced concepts and features we need to study in DBMS. Yeah. So these concepts, these features, very important. Yeah. So let's go there. Oh, yeah. So here, after I finish this Part D, I plan to create a set of exercise questions for you to practice. Okay? So covering Part B, C, D, 3 parts. A, we have nothing, right? A, we just talk about syllabus. So no material for Part A. Yeah. But a B, C, D, yeah. So we cover, a lot of things, a lot of knowledge, but scattered. Yeah. For you, if you just look at the notes, so many little pieces you may not be able to catch. So let me make a set of exercise questions. I try to put together all the knowledge pieces, making questions, so you can practice. Okay, yeah. And in that exercise question sets, some of the questions I will put in quiz or homework assignments. Yeah. So some of the questions, let me do this way. Yeah, probably, 1/2 of the questions will go to quizzes or homework assignments. The other half, I will give you answers. So you can study, self-study. Yeah. So 1/2. Yeah. Half. Yeah. All right. Looks like there is something. Yeah. Let me turn off my cell phone. Yeah, because I'm afraid I get some call. Yeah. All right. Yeah. Advanced features. Here, let's see several advanced features. All right. Oh, sorry. Yeah. The first one, transactions in DBMSs. Yeah. This advanced feature. What's that? Yeah. This transactions is quite different from our usual understanding transactions. Yeah. Bank transactions, business transactions. It's different. In our database transactions, our definition is very special. Yeah. Yeah. Because when we do the programming, you need to have this concept. Yeah, many times you need to know you are doing business transactions. So you need to do special treatment. First, let me describe the basic concept transaction. So what's a database transaction? Definition of a transaction. Database transaction here. In our database context, you understand it this way. Okay? Now the business context. So here, particular database context. So what's that? Define a business task containing a sequence of, so here, a sequence of business database accesses. All right. And these database accesses are correlated. There is some close relationship among these database accesses. And you cannot separate these business accesses. If you separate them, part of it, then something could be wrong. Something could be wrong. So that's this kind of special requirement comes from the business world. In business world, it's quite common. There is some integral business task. You cannot separate. You have to complete the whole task. Otherwise, if you cannot complete the whole task in one block of processing time, you would rather go back to the original point. Do nothing. Do nothing. Don't do part of it. Don't do part of it. You have to do it as a whole or not. Okay? You only have two options. Complete the task as a whole or nothing. Don't do anything. That's a typical business requirement. So here, a typical example is, let's consider a sequence of banking transactions. Think about it. You have two accounts. For one account, you withdraw certain amount of money from one account, right? So that's the first banking transaction, but it's a one database access in the business task. After you withdraw the money, you want to make a deposit to another account immediately. Okay? You don't want to, make it, idling outside any account, right? It may not be good. So you want to put it into another account, all right? So you want to make these two actions work as a whole task. You don't want to break it in the middle as a whole task. If something is wrong between these two steps, okay? So here, I try to avoid using transactions because we get confused. Business transaction and a database transaction, so we may get confused, okay? If something is wrong, for example, the electricity problem, okay? Electricity, the system breaks in the middle, earthquake, for example. You complete the first step, but you haven't started the second step. Then some system, problem, shut down, the system breaks, you cannot complete. Then your business text has some severe problem, right? So you want to avoid it. In business, you want to avoid whenever you need to complete an integral task, you want to avoid anything goes wrong in the middle. Okay? That makes sense in the business. So how do you ensure nothing is wrong or no damage if something is wrong in the middle. No damage, damage control. Okay? So you don't want to make any severe damage due to the something happens in the middle. Yeah. So this transaction feature must be implemented in DBMS. DBMS doing some very special, lot of work to protect your data, your business data. It's a built-in feature in DBMS. Okay? Built-in feature. If your DBMS is good enough, production quality DBMS, it must support this transaction feature for your business. Otherwise, almost all business require this transaction feature. Okay? Yeah. All right. So here, first, the concept, the importance, the concept. Yeah. All right. Then, here, example, withdraw from account A, deposit in account B. Yeah. You cannot break it. Okay? If something is wrong in the middle, you would rather go back to the original point. Do nothing. Yeah. Put the money back to account A. Okay? Do not take it out. Yeah. But if you have time to do it, inside DBMS, it will guarantee that you go back to the original point without any damage. Because you do nothing. You do nothing. So no damage. Yeah. All right. No separation between them. Yeah. Yeah. But the question is how to implement a transaction. Yeah. Inside DBMS, how to implement transaction. Yeah. So here I just describe the general idea of the transaction. Okay? You need to define starting point, right? You need to define that block, that sequence of database accesses as one transaction. Otherwise, the DBMS does not know what group of data accesses are treated as one transaction. The DBMS does not know that. You, as a programmer, you need to tell DBMS how I define a transaction block of database accesses. Yeah. All right. Yeah. Define the starting point of a transaction. Oh? Yeah. So here, let me use the Java way. Okay. So in Java, begin transaction. Yeah. In Java, you need to use statement, begin transaction. Transaction. Okay? Yeah. Then a block of code. A block of code. All right. Begin transaction. Yeah. But at the end of the transaction, you need to commit. You need to issue that commit command. Commit. That means DBMS, after it receives this commit command, it executes a whole block of code, query at the same time, Yeah. All right? Yeah. Yeah. So define starting point of a transaction. Yeah. Then, inside, provide a sequence of queries for the task. This is the sequence. Okay? Yeah. After begin, you provide query 1, query 2, query 3, a sequence. Yeah. At the end, commit statement. All right? So commit the transaction. Yeah. All right. So then, let me explain how does DBMS handle this transaction block of code. All right. So the DBMS, after it receives the first database access query, it just compile it and put it in a queue. All right. Don't execute that command. Hold. Okay. Yeah. Don't execute. Yep. Put there. Yeah. Second one, compile, put in the queue. Third, compile, in that queue. Yeah. Then all of them put together in that queue. All right. Commit. Yeah. Before you receive commit, don't execute any command. Okay. Don't execute any command in the queue. DBMS. Hold it. Yeah. Hold it. Yeah. So in the queue. All right. So the first command, second command, third command, yeah, do not execute any of them, all right? Until the last one, you put a commit here, okay? A commit. Then execute from beginning to end, all together. Because you have all the command you compiled together, so execute from beginning to end in a short period of time. Okay? In a short period of time. Yeah. All right. But when you do that, put in the queue, when you do that, yeah. If anything happen in the middle, because you have not executed any of them, right? If anything bad happens in the middle, because you haven't executed any command, then you just go back to the original point. Undo everything, because you haven't done anything, right? So you can just move back to the original point, then you avoid the potential problem. That's the basic idea. Implement transaction feature inside DBMS. So whole or not, only two options you can take. Only execute as a whole or not. Okay. In Java, when something happens, that means there is an exception throw. Yeah. When exception throw, then Java will roll back to the beginning point of the transaction. Roll back, nothing. Yeah. You do not do anything in the database accesses. Yeah. So that's the Java way. Okay? Other programming languages, similar. Yeah. Just small details, that part could be different. Yeah, because it may use different words. Yeah. Same meaning, same concept, but it used different terms, yeah, for other programming languages. Yeah. All right. Roll back if there is an error. If there is some error, think about, error. So here, automatically, the system, the DBMS built-in system, automatically, it rolls back to the beginning point. But people may argue, if the electricity suddenly, shut down or stoppage electricity, how do you have time to roll back, right? When you do roll back, it takes time. It takes small amount of time. But electricity stoppage happens suddenly, you may not have enough time to roll back, right? So that's because there is some backup of battery thing, right? Short period of time. So when electricity not available, still some UPS UPS battery, that kind of thing, right? Still, you have a few minutes. You have electricity from the battery, backup battery. You just need a small amount of time, you can roll back, okay? You can recover to the original point. Yeah. All right. Yeah. Here. Yeah. The property, here, let me talk about the properties for this transaction. Yeah. First, isolation property. Yeah. When the DBMS implements, let me look at the time control, implements this feature, isolation. What do you mean isolation? Because inside one DBMS, you may have multiple transactions executed at the same time, right? Transaction 1, transaction 2, transaction 3, several transactions are executed inside DBMS at the same time. Then, isolation means each transaction is isolated, okay? Yeah. So there is no interference between different transactions. Must be isolated. Yeah. So that's the first property. Yeah. No interference from other transactions. Yeah. Second property, atomicity. Atom, we know atom, right? So atom, very old time, people understand atom as non-separable particle, right? Yeah. At a very old time, thousands of years ago, people treat atom as a particle that cannot be separated anymore. Although we know it's wrong. Atoms can still be separated to smaller particles, right? Neutrons, protons, electrons, right? Can still be separated. Yeah. But here, people just use that, an object that cannot be separated. Yeah, this property, people use atomicity, okay? Non-separable. Yeah. You have to treat it as a whole object. Yeah. You cannot break it. You cannot separate it. Yeah. Atomicity, yeah. The second property, okay? All right. All or none database operations are executed. You can either execute all the operations defined in this transaction or not. Not part of it. So that's the atomicity property. So these two properties for a transaction concept. All right. All right. Yeah. Then the second one, concurrency control. Here, Microsoft. Yeah. I will talk about this. Microsoft is a little special. Microsoft Access. Yeah. Let me talk another important concept here, concurrency control. Yeah. This feature, another advanced feature, important feature. Every production level DBMS must have concurrent. Yep. So from the name, multiple database queries implemented at the same time. Yeah. For typical web applications, DBMS need to do a lot of concurrency control. Yeah. Support that several users trying to update the same data do so in a controlled manner. Not messed up. Yeah. Because here, so there is a, multi-threading. Yeah. So if you have the multi-threading concept, yeah. So here typically, time slicing, multi-threading way to allocate CPU execution time to different users' requests. Because in that way, each user, they can see the progress of their own business task, right? Yeah. Otherwise, if you complete a sequence of tasks in sequential order, then some users may need to wait a long time, no response. Yeah. Yeah. So here, in order to improve the user's experience, so the CPU execution time is divided into time slices and allocate to different users, take turns. Every period of time, so one user gets its processing time. So all the users can see their business task in progress. But the control, some very complicated control inside DBMS should support this feature, concurrency control feature. All right. A good DBMS must include this feature. So here, this place, I want to talk about this Microsoft Access. The newer version, the current newer version, because we know Microsoft Access is for small business. Actually, for mainly, its original purpose for single user, home user, single user. Okay, even if for multi-users, it may not be a good one, may not be a good DBMS. Typically for single user. So the early version of Microsoft Access, 10-something years ago, Microsoft Access did not support concurrency control. Every time only one user can access. No time slicing way to support multiple users. So I had that kind of experience before. Some of you probably you have that kind of experience because I noticed some small business, some organizations, small business, when they wrote their web applications, some of them use Microsoft Access as their DBMS. So usually when you do that, if there are certain number of users, dozens of users, let's say, not a too big number of users, dozens of users access at the same time, then the system slow down significantly. Many people, they need to wait a long time because no concurrency control features. It's a single user DBMS. You have to wait one complete, then after another one, then after another one, So I saw that kind of, real world experience. But recent versions, so Microsoft increased that concurrent user, that supporting number to 255. That's pretty good, because for a small business, at the same time, you can provide services to this many users. That's good enough, right? For home business, not for mid-size home business. Good enough. So that's the related to this concurrency control feature. All right. All web applications require this feature for data accesses. So that's why MySQL is a much better, much more powerful DBMS than Microsoft Access. It can provide thousands of, even millions of concurrent users. Much more powerful, MySQL. Okay. The transaction feature requires this feature. All right. Right. So that's the So I saw, several examples, based on my personal experience. All right. Then, so this is the second advanced feature, concurrency control. Third one, stored procedure. This is the third advanced feature for DBMS, stored procedures. That's programming, okay? That's something if you are database programmers, sometimes you may need to write programs for DBMS. So we call it stored procedures. Now, what's that? Let me describe the stored procedures. In form of functions, procedures just same meaning as functions. Same meaning as functions. So in many old programming language, it's called, some old phrases are used, like subroutine, right? Fortune, subroutine, Our modern programming language, we use functions. All the programming languages, one is subroutine, another procedure, okay? SQL is very old. We know SQL is a very old programming language. So it uses procedures, this particular word. But at the same time, it also uses functions. SQL has two different names used for similar purpose. Procedure one, and a function one. They are slightly different. The usage of these two words slightly different. All right. Stored procedures are written in SQL. The code written in SQL. You can use SQL language to write definition of the stored procedure. Just similar to your usual programs, but you use SQL to write. Okay, Execute a sequence of SQL statements in DBMS. So in your function definition, so you write a sequence of SQL statements. And this function would be compiled inside DBMS. Compilation, same thing as you do in other programming languages. Compiled in DBMS, and then execute it. Execute the machine code, binary, executable code. So internally, the same way. This procedure definition, you need to write a code, so you define a procedure. Okay? So you create a procedure. In the procedure, you need to provide input. Input, output. Okay? It depends. And when we work with functions, sometimes we don't have output, right? Void. Sometimes no output. We only do data processing. No output. And sometimes we have output. So the procedure, so this block, no output. But sometimes you want to get output, right? Then you need to use a different name. You use function. Okay? Function, so you get input, and return output. Output, so you always return output. inside sequence of SQL commands. Sequence of commands. Okay? Yeah. So then compiled and then run. And then you can call. Yeah. Because the procedure, you have a name, right? So you have a name of the procedure. Function, you have a name of your function. Yeah. Then you just call procedure. You call that function. Then it's executed inside DBMS. Yeah. Yeah. And the code you write belongs to database definition. Database definition. Yeah. So for each database, okay, so here, one database, you have two parts. When you make one database, you have two parts. First, the definition part. Definition part. Okay? You define tables, functions, constraints, domains. You define a lot of things you need to use in your database. So that's the definition part. All right? Yeah. The second part is the data part. Yeah. So not the business data part. So these two parts for each database. Okay? All right. The definition part we also call metadata. Metadata. Okay? So it is not the original data. Original business data we call the data. But metadata, that's the descriptive data. Okay? The data is used to describe other data. Yeah, so it's the metadata. Descriptive data. Yeah. So that's the definition part. Okay? So two different parts for each database. All right. And stored procedures belong to the metadata, the database definition part, because it's not a business data. Okay? It's the SQL commands. The business data, that's the data part. Okay? Yeah. The real world data part. Yeah. All right. Can be called locally and remotely from application programs. Yeah. Locally, that's from DBMS. In your DBMS, you can, so there is a SQL window. You can type SQL command. So you type call your procedure name. Yeah, you run it. You run this function. So that's the local call. Remote, yeah, you want to call store procedure that's stored in a different machine. Remote machine, remote server. Yeah. Remote server. Yeah. So then, you do it in your application program. Okay? Your application program. You can access remote database server through URL. Yeah? The database connection, there is a URL. Connect to the remote database. Then you send a command to remote database. Call my procedure. That's in your application program code. Okay? Yeah. So that command is sent through the database connection to the DBMS. Then the DBMS call the procedure for you, return the data back. So if there is some output, the data is returned, so you get output data. You can do processing. Yeah. All right? Yeah. So that's the remote way. Yeah. All right. Can be created in application programs. So here, what's the meaning of this? Yeah. Here it means can be. the stored procedures can be created inside your application programs. For example, you write a Java program. Okay? Yeah. You have a DBMS on a remote server. Yeah. A different server. Your Java program working on a current web server. It's in this location. But the database is at a different location, remote location. Okay? All right. But now you want to, in your Java program, you want to define a stored procedure in that remote database server. You can do it. You can do it. Because basically you just execute SQL commands. You use a sequence of SQL commands. You run SQL statement one by one. Okay? After you finish all these commands, one remote procedure is created. Yeah. Then, after you create it, remote server, you can call it. So then it works remotely. Yeah. Question? Yeah.
It's not practical, right? I've been told not to do that.
Well,
You can, yeah. But
yeah. You mean you feel it's not good?
Yeah.
Oh, actually, no. Actually, you cannot say it's not good. Yeah. Because you as a programmer, you need to get permission to do that, right? First, because permission through your account, right? When you create a database connection, you use your account, username, password. Suppose you are the same user, you have that privilege. Why you cannot do that, right? Yeah. Because if you're not allowed to do that, a lot of things, a lot of important things you cannot do. Okay? Yeah. So here, yeah. But you point out important question. Sometimes the capability and if you're allowed to do it, two different issues. Yeah. But one similar situation, similar to what you said, at the client side, we cannot access data. Okay? At clients, we have the capability to access data, database. At the client, that's JavaScript. When you write JavaScript, you can access the database. But don't do it. Never do it. Yeah, yeah, that's a different situation. But here in Java program, you work at the server side, right? When you write Java code, it's always at the server side. At the server side, you're allowed to access database. Think about when you do DBMS, you access a remote database, right? You do queries on remote database. How do you use DBMS? Yeah, you have to use DBMS, right? And most of the time, it's a remote access, right? Yeah. When you do DBMS, that's this. Because DBMS, you can execute SQL commands, right? When you execute a sequence of SQL commands, you create a store procedure already, right? Yeah. So that's different thing. So the concept is, if we're working at a server, we're allowed to access any data, okay? Any database. But if we are in a client, no. You can never directly access. You can indirect. You can call a Java function to a Java program to access database. But you cannot access yourself, okay? You have to use other resource to access, yeah? So that's different. But yeah, but it's good to clarify, okay? Yeah, it's good to clarify when we can access database, when we cannot. All right, yeah, so here we finished the 3 important procedures, yeah? So it's a very important, yeah, so let's stop right here, yeah. So we will continue next time, yeah.
Since that key is probably $1,000, I don't know.